Welcome to this class. In this short session, we are going to state without proof basic properties of limits. And then next session, we'll do examples on how to apply those properties. So let's limit as x approaches a of a function f of x be given by L1 and limit as x approaches a of a function f of x, g of x, be given by L2. Also, let n be a positive integer, k be any real number, and p and q be integers such that q is not equal to 0. Then the following properties are true. So the first one, we'll start with what we call the sum rule. One, the sum rule. So the sum rule for limits states that limit of sum of two functions. So limit, so remember here f of x and g of x are any two functions whose limits are defined. So limit as x approaches a of f of x plus g of x is the same as limit as x approaches a of f of x plus limit as x approaches a of g of x, which is just the same as L1 plus L2. So this means that limit of sum of two functions is the same as sum of limits of the two specific of the two functions. So number two is what we call the constant multiple rule. The constant multiple rule. So the constant multiple rule states that the limit as x approaches a of k times a function f of x, where k is any real number, is the same as k times the limit of this function f of x as x approaches a. So this is the same as k times L1. Number three, the product rule or the product law. Actually replace this rule by just the term law, so that by just stating the properties. So this sum, the sum law, and then let this be constant multiple law or property. So the next one is product law. So the product law states that limit as x approaches a of the product of two functions f of x times g of x is the same as limit as x approaches a of f of x times limit as x approaches a of g of x. So it's the same as L1 times L2. So limit of product of two functions the same as product of their respective limits. And then number 4, what we call the quotient law. The quotient law. So quotient law states that limit as x approaches a of the quotient of two functions f of x over g of x is the same as the limit as x approaches a of f of x over limit as x approaches a of g of x, which is the same as L1 over L2, provided that L2, which is the limit of the function g of x, is not 0. And then number 5, is called power rule, power and roots law. So this one says that limit as x approaches a of a function f of x raised power p over q is the same as you take limit x approaching a of the function f of x, and then you raise to power p over q, provided q is not equal to 0. And then number 2, limit as x approaches a of f of x, the square root, the nth root of f of x is the same as limit as x approaches a of f of x, and then you get the nth root of that given limit. This n is a positive integer. So that's those are the properties. And just to sum up, ways of evaluating limits. Ways of evaluating limits. So one, the obvious method is what we call substitution. Substitution. Method. If substitution doesn't work, we can do what we call factorization. Method. If factorization doesn't work, you can try to do rationalization if you see SADS. So remember, rationalization is both rationalizing the numerator and denominator. And then number 4, we have what we call L hospitals. rule. So these are some of the methods of finding or evaluating limits. So the next session will be discussing how we can do the evaluation of limits using some of these methods we have listed here. So thank you.